Hello everyone, we've got a nice probability distribution question here, exam question. So let's see what we've got. It says Julia selects 3 letters at random, one at a time, without replacement from the word variance. The discrete random variable x represents the number of times that she selects the letter A. Find the complete probability distribution. Okay, well, let's think. So Julia can either select the letter A once, no, she cannot select it at all, so 0. She could select it once, or she could select it twice in her 3 selections. Okay, so we're going to say let x equal number of times A is selected. Okay, so A is the number of times that the letter A is selected. So let's first of all, let's work out the probability that x is equal to 0. Okay, now, so first time when Julia selects one, if she doesn't select an A, there are 6 letters there that do not have an A in out of the 8 altogether. Okay. On Julia's second choice, there are 5 letters that do not have the letter A out of the 7 remaining. And on Julia's third selection, there are 4 letters out of the 6 that remain. Okay. And there's only one way we can do this, because we do need to think about the order in which this can happen. So this is technically 3 choose 0. If you want, we could say it's times by 3 choose 0. You do have to be careful about that. But 3 choose 0 is 1. So our answer here is 5/14. Okay. Now, probability that Julia selects 1. Okay, so let's imagine Julia selected an A on the first time. So that is 2/8. Then she does not select 1, which is going to be 6/7, because there are 6 letters that do not have an A in remaining. And then 5/7, because there are then 5/6, sorry, because there are then 6 remaining. 5 that don't have an A out of 6. So this is selects an A, not A, not A. In fact, you could write down this is not A, that's not an A, that's not an A. This is an A, that's not an A, that's not an A. Now, the thing we need to be careful of here is, and this is where it's easy to make a mistake with this question, is you could just leave that and write down that probability, but that would be incorrect, because Julia might select an A first time, okay? She might select an A the second time, and it might be that she selects an A on the third choice. So in other words, she might have not A, not A, A, or she might have not A, not A. So in order to do that, we need to times this by 3 choose 1, because it's the number of ways of choosing one item out of 3, which is just 3. So because there's just 3 ways that can happen. Either she gets it first time, second time, or third time. When we work that out, that probability turns out to be 15/28 when we calculate that one. All right, next, probability that x equals 2, that Julia selects 2 A's. So let's imagine she selects an A first time, which is 2/8. So that's A. She selects an A second time, so now it's going to be 1/7. That's another A. And then not A, which is going to be 6 over the remaining 6. Okay, but again, the order in which these happen is the not A that Julia selects might be on the last choice, the not A might be on the second choice, and the not A might occur on the third choice. So there's 3 different combinations of ways that this can happen. And this is technically our 3 choose 2, because we're choosing 2 A's out of our 3 selections. Okay, so we need to times that by 3 choose 2, which is just 3 as well. So that ends up as 3/28. Okay, now if we are correct, we can do a little test here. You don't have to do this, but this is just a quick check just to see whether or not we are correct. Because if this is correct, all of these should add up to make 1. Okay, and when we add them together, they do in fact add to make 1. I'll just write there's a check. So they add together to make 1, which is really encouraging. So let's write down our complete probability distribution in the way in which we'd be expected to write it down. So here we go. So we've got x is 0, x is 1, x is 2. Let's have a look at this. So 0 we've said is 5/14. 1 we've said is 15/28. and 2 we've said is 3 over 28. So there's our complete probability distribution. 5 marks. Nice question. Yuki selects 10 letters at random, one at a time with replacement from the word deviation. Okay, find the probability that he selects the letter E at least 4 times. Now, it's always tricky this. You've got to think to yourself, what kind of a distribution have we got here? What kind of a distribution? Well, we've got a fixed number of trials because Yuki selects 10 letters. So we could write down n equals 10. And the fact that it's without replacement, with replacement rather, means that the probability stays the same all the time. And the probability of selecting the letter E is 1/9. So this is an AS paper anyway, so really we've only got one choice. It's going to be a binomial distribution. Because remember, a binomial, we used it when we have a fixed number of trials, we use it when we have a constant probability, and we use it when the results are independent of each other, okay? And they're independent of each other because of the way that Yuki puts the letter back each time. So here's our distribution. It's a binomial distribution with 10 as our n, a 9th as our p, and we're asked to find out at least 4 times, which is probability speak for greater than or equal to 4, okay? And again, depending on your calculator, you may need to work out probability of x. 1 minus x is less than or equal to 3, or you might be able to calculate it directly if you have a more advanced calculator. But when we work this out, this turns out to be 0.0184, and that's the answer. That's a super nice, easy 3 marks for part B. Hope you found that helpful. That's a second question there. This one we're looking at probability distributions. I'll see you all in the next video.